Six Sigma. It is actually a set of tools and techniques that are used for improving a process. It was first developed by two engineers, Bill Smith and Michael Harry, who were working in Motorola in 1986. And the concept of Six Sigma is to reduce the variability in critical to quality characteristics to a level at which the failure or defects are extremely unlikely. And the tool that is used for the implementation of Six Sigma is DOMAIC, that we have already studied in detail. And you know that DOMAIC is an abbreviation of the words define, measure, analyze, improve, and control. These are the 5 steps actually which are involved in the DOMAIC process, which helps in implementation of Six Sigma process for improving a Six Sigma methodology for improving a process. Okay, now let's take a deeper look into Six Sigma. This graph shows a normal distribution that is centered at a target value t. So the target value is the actual value that we aim for. So the x-axis of this graph is actually as multiples of sigma. Sigma means standard deviation. This sigma also means standard deviation. So this one actually a probability distribution graph. So if we have the limits set for ourselves, we can calculate the probability of some data to fall within those specification limits. For example, if we have plus minus 1 sigma as our specification limits, means plus 1 sigma and minus 1 sigma, this one as our upper specification limit and this one has our lower specification limit, then from this graph we can calculate that 68.27% means within this range we will have 68.27% of the data that is falling within our specification limits. So in terms of the manufacturing process, we can consider that if our acceptable range is between plus minus 1 standard deviation, the conforming products or the acceptable products that will fall within that range is 68.27%. It's not a good percentage of conforming products, because the defective products or non-conforming products will be 31.73% in this case, right? So if we talk it in terms of parts per million or the number of products per million that will be defective, goes to 317,300 defective products. This is close to like a third of the lot. Means if you are making a lot of 1 million products, almost a third of those products will be bad. So it is really a bad situation for a business. So it is not acceptable that a process that is giving us so many defective products. So now if our acceptable range or our specification limits are between plus and minus 3 sigma, plus 3 sigma is the plus 3 standard deviations upper specification limit and minus 3 sigma as lower specification limit, then within this specification limits, the data that falls in this range is 99.73%. In the coming lectures we will see how we calculate it. So the 99.73% will be conforming products if our specification limits are set at plus minus 3 sigma or plus minus 3 standard deviations. So in that case, the number of defective products in part per millions reduced to 2700. Huge improvement, huge significant improvement above the 1 sigma plus minus 1 sigma specification limits. So this is called as 3 sigma quality performance. So 99.73% of the products will be conforming. That means that there is a probability of 99.73% products to be conforming or acceptable, and only 0.27 products, only 0.27% of the products may be defective or bad products or non-conforming products. So if we means talk in terms of parts per million, 2700 products out of a million products may be defective. Now let's take a look at an example of 3 sigma performance. So let us consider that we have a product which is an assembly of 100 components, means 100 components joined together to make a product. That may be a toy car or something like that. So all 100 components must be non-defective for a product to work satisfactorily. Means that if a product has to be conforming product or a good product, all 100 components must be non-defective. If even one of the component is defective, the product will be rejected or will be considered as defective or non-conforming, right? So in this case, our specification limits are plus minus 3 sigma. Okay, so our means that the probability of each component to be good is 99.73% or 0.9973. So we can write a formula, or we can calculate the probability of one product to be conforming or good product is like this. So 0.9973 is the probability for one component. We have 100 components, so we will multiply it 100 times. So it becomes like this, 0.9973 raised to the power 100. And when we calculate the probability of one good product is 0.73 or 0.7631. So it is around 76.31 is the percentage of the products of one product to be good. Okay, if it is consisting of 100 components. So it is not a very good percentage or not a very good probability of a product to be defective, conforming. So in other terms, we can say that if we are making 100 products, then the 76% of the products will be conforming, which means that 23.7% of the products will be non-conforming, right? So out of 100, if 23.7% of the products are non-conforming, this situation is not attractive at all, and it gets worse very fast, because in the bigger productions, like in the products which are composed of more than 100 components, like vehicles or automobiles and the aeroplanes, are a lot more components. Automobiles typically contain 100,000 components, and aeroplanes 1 to 2 million components. So you can easily see by replacing this 100 by 100,000 and 100 by 1 to 2 million components, you will see that how quickly it gets worse. So it is not an attractive situation for such productions, right? See 6 sigma. What 6 sigma means here? That means how bigger of an improvement 6 sigma is. So if we consider plus minus 6 sigma as our specification limits, means that this is our upper specification limit and this is our lower specification limit. Then the data that will be the percentage of the data that will be within these two limits will be 99.9999998. This is like almost 100% of the data that is, or the almost 100% of the products will be conforming, right? So because almost all of the data is within the specification limits, within the acceptable limits. So by data I mean that the measurements, the CTQ characteristic measurements, so that can be thickness of something, or for example, in the simplest example, the diameter of a ball bearing ball. So these are the measurements of that. If all the diameters are within the acceptable range, our 100% of the products will be conforming, right? So if our specification acceptable limits range from plus 6 sigma to minus 6 sigma, the probability of having conforming products is 99.99998%. So how many products will be defective then? So out of a million, there are chances of 0.002 products to be non-conforming or defective. This means less than one product, of course, out of a million products. This is an excellent situation. It is called as Six Sigma quality performance. So it means that we have a million products and not even one product is defective. However, this is not the real situation. In their initial development of the Six Sigma program in Motorola, there was an assumption made. That initial assumption was actually that as soon as the performance approaches Six Sigma quality, the mean of this distribution also fluctuates. So it fluctuates between the range of 1.5 sigma to minus 1.5 sigma. Means this actual distribution graph shifts. So this was the first assumption, the initial assumption that was made, that the normal distribution with mean is shifted plus minus 1.5 sigma from the target value, right? So this is the actual one, the ideal one, but it fluctuates as the performance of the system approaches to 6 sigma. Then the percentage of the data inside the acceptable specification limits is this one. So means that the number of the percentage of the products inside the acceptable specification limits has been changed. As you remember from the Six Sigma in the previous on the previous slide was 99.9999998. Now it is reduced to 99.999660, and the number of defective products increases from 0.002 to 3.4. It is still very low, means 3.4 products may be defective, because there's probability of having 3.4 products to be defective out of 1 million products. An excellent situation for the business, right? So that's why the businesses prefer to introduce this performance in their businesses. So rather that be it can be a manufacturing process or the service or there's the service business. So whatever the business is, the chances or the probability of having defectives or complaints in the service, that is 3.4 out of a million chances. It is an excellent one, right? So after the Six Sigma was introduced to the world by Motorola, after of course the implementation at their own company, they showed some excellent results. The other businesses, big businesses, started to adopt it. So it evolved over the time. The first generation was of course developed by the Motorola, and the focus of that part was, means when it was developed in the first generation, the focus was to reduce the defects, means the defect elimination, eliminate the defects as much as possibility, and reduce the variability. The reduction in the variability and the defects, the reduction in variability means that reducing the standard deviation. In other terms, we can say in the statistical terms, the variability is the deviation, and reducing it to the maximum possible extent. So the leader in the implementation of generation 1 was obviously Motorola, because it developed it introduced to the world after implementation it in their own company. Okay, so they had they got huge benefits from it. So after that, the next generation of means that built upon generation 1 focused on defects elimination and variability reduction of the generation 1, and included one more very important aspect of cost reduction. So in addition to defects elimination and variability reduction in the process, they also focused on the ways to reduce the cost of the production to gain, of course, more benefits and revenue for their company. So the company who was the leader for in the implementation of generation 2 of Six Sigma was General Electric. So after Motorola, it was actually developed. Motorola developed it in 1986, and General Electric adopted it in 1995. So almost 10 years after that. So they improved it by introducing another factor or very important aspect of cost reduction in order to have more financial benefits, to gain financial benefits for their company. So they had three aspects of focus in generation 2. So on the top of generation 2, the generation 3 was developed. So the generation 2, the focus points of generation 2 were defects elimination, variability reduction, and cost reduction. So on top of these three aspects of focus, or the points they focused in generation 2, there was an other aspect that was introduced to these focus points, was the value addition. Value addition is very important. The value addition for all the stakeholders, for the shareholders, for the customers, for the employees, and everyone associated with the company. They introduced the value addition. So the leaders of the implementation of generation 3 are Caterpillar Inc. and the Bank of America. So these are the two who implemented generation 3 of Six Sigma and took the lead in that. Six Sigma rules are given according to the Japanese martial arts. So Japanese martial arts, they judge their skill level from the color of the belt the player is wearing around the waist. So here similarly, they have in their hierarchical structures, they have these belts. So yellow belts, green belt, black belt, master black belts. So these are the skilled people in implementation of Six Sigma. So yellow belts are at the bottom, then green belts are better equipped, and the black belts and the master black belts sit on the top with the highest skill in Six Sigma roles. They work with project members. So actually these belts, the people having belts belts are actually certificates. You can consider them as the certifications, different levels of certifications. So they can individually lead the projects, and they implement it with the help of project members. So all of these have full-time roles in the Six Sigma projects. But champions, they sit on the top like the management. They take the feedback from them, and they provide the necessary resources that is required for the implementation of the Six Sigma projects. So the champions do not have full-time role in the Six Sigma implementation, because they are the people with the certifications, and the project members, they take care of the project, and the champions, they facilitate them to implement it. And then there is the top company leadership that is overseeing the whole process, right? So this was the hierarchical structure of Six Sigma, means the implementation of Six Sigma, how they report to each other. And after this, there is another variant, you can say, of Six Sigma, that is Lean Six Sigma. Actually, the lean is the term of stripping of or elimination of the waste. So if we have lean, if you consider the lean, for example, the most common term, the lean meat. The lean meat is the one that is the meat only and without the fats, right? So the fat is considered as the waste in the meat. Okay, so the lean one is the one that has been cleaned up of the fats. So in the lean Six Sigma means that in this we focus on the elimination of the waste from the Six Sigma or from the process, right? So by waste we mean that the activities which do not add any value to the process, right? So in lean Six Sigma our focus will be on identification of non-value adding activities and then eventually the elimination of it. So the examples of the waste or non-value adding activities is unnecessarily long cycle times and or the waste or the waiting times between value added activities to be performed. So it means that the waiting times or unnecessarily long production times are considered as the waste of time that can be used for value added activities actually. Okay, and the second is rework or scrap. So rework requires the use of resources and time. Okay, and scrap is the waste of everything, like the time that was spent on the product and the material that was spent on the manufacturing of the product, that is going to scrap. Okay, the rework means reutilization of the material, but it is a wastage of time. And if a product is going to scrap, it is a waste of time, money, material, and everything. So these are the types of the waste that lean Six Sigma intends to or attempts to eliminate in the process also, right? So there is a metric that help us identifying or help us in making a lean Six Sigma process, that is called as process cycle efficiency, right? So it is calculated with this formula: process cycle efficiency is equal to value add time divided by process cycle time. Means that the total time of the process, that is the process cycle time, and the value added time, that the time that is used in value addition. So if the process cycle time and value added times are equal to each other, the process cycle efficiency will of course be 1. Means that 100% of the process cycle time consists of the value added time. Means that there is no waste time in this case. Okay, so if you want to define it, the value added time is the amount of the time that is spent for adding value to the process. Okay, and the results in something for which the consumer is willing to pay, right? So anything that is done in order to earn the money, that will be called as the value added activity, and the time spent in performing that activity is called as value add time, right? And what is the process cycle time? The process cycle time is calculated like this: the work in progress divided by average completion rate. So the work in process is, for example, you have 1500 products to make, right? And average completion rate for completing one product is like 1 hour, right? So that's how you will calculate the process cycle time. How long this process will take time, how long will this process take in order to complete work, right? So work in process is 1500 products, and the time to take to complete one product is 1 hour. Then the 1500 hours is the process cycle time, right? So the average completion rate is the capacity. The measure is actually the measure of the capacity. What is the capacity of the system, i.e. the output of the process over a defined period of time. As I just mentioned to you, the total the workload divided by the average completion rate. So by doing so, we can calculate the process cycle time. Okay, now there is another process that is designed for Six Sigma. It is Six Sigma. Design for Six Sigma is slightly different from that. So it means in the last few lectures we have acquainted ourselves with the term of design experiments, right? So that design and this design are the same things. So that this design is specifically for the Six Sigma process. When you want to implement Six Sigma in our business or our process or for any other activity, so we take Six Sigma to the lab. You can consider we are taking it to the lab and then perform some experiments on it. So design for Six Sigma is an approach for taking variability reduction and process improvement philosophy of Six Sigma from manufacturing or production into the design process. So this part, the variability reduction and process improvement of Six Sigma into the manufacturing or production, it is the implementation of Six Sigma into the production department, right? So whatever is being manufactured or produced, it is the implementation there in the field. But in design Six Sigma, we take it from there and bring it into design process. Okay, design process is before sending any process to the manufacturing. Okay, so design process is the process of refinement. Okay, so we implement it for the products and processes both. And what is the product actually? The product is anything that is sold to a consumer for use is referred to as a product. Okay, and what is a service? The service is an activity that produces value or benefit to the consumer is referred to as service. So you can relate it with your daily life experiences, that what are the products that you encounter with and you know and you are familiar with, and what are the services that you are familiar with. Okay, now what is the difference between Six Sigma and design for Six? The difference between the Six Sigma and design for Six Sigma is that, as we know, that Six Sigma is implemented in the manufacturing and production part, right? So Six Sigma focuses on the operational excellence, so to get our system to an excellent condition, to the excellent state. And the tool that is used for implementation of Six Sigma is the mic, right? You are very much familiar with this term now already. So, and the design for Six Sigma is actually focuses on increasing the sales revenue generated from new products, services, and also finding new applications for the existing ones. So now you can see that design for Six Sigma is a value addition on the Six Sigma. So this is operational excellence, and this one is increasing the revenue, sales revenue from the new products. Why the new products? Because when we are going into design process, so the design for Six Sigma focuses on the new opportunities and the new products that can be produced, or that can be produced with their existing setups, or if there's something new required for the new products in addition to the existing ones, they also think about that. So how they do it, they conduct surveys on the customers. The team that is working on DFSS, they conduct surveys from the consumers, they get their feedback. Okay, on the after analyzing the feedback, they design new things, they design new products, they design new services, and also they find out new applications for their already existing products and services. So this is a huge value addition to their business, right? And the tool that is used for DFSS is almost similar to DOMIC, but with a little bit of addition or modification to it. So DMAIC is DMAIC. So DMA are the same. The change or the modification is in the last two steps. They are now D and V. So define, measure, analyze. Now this D is design, design, and V is for validate. So the major tool that is used for Six Sigma is DMAIC, and the major tool that is used for DFSS that is related with DMAIC is DMADV. So that's all about the Six Sigma. So if you have any questions, we can discuss during our live sessions. Thank you very much. Have a good day.